Today we solve exponential and logarithmic equations. So we have two properties, two one-to-one properties, and then two inverse properties that should be familiar to you. The one-to-one properties were from section 3.1, and they said that if we have like bases, the powers are going to be equal. Or if we're taking the log base a of x and it's equal to the log base a of y, then x equals y. No surprising revelations there. When we look at the graph of an exponential function and a graph of a logarithmic function, those two are reflections of each other over the line y equals x, because exponentials and logs are inverse operations. They're inverses of each other. So if we have a log base a of x and we raise a to it, our result will be x. And if we're trying to clear an a to the x, we simply take the log base a of a to the x, and our result is the power. So those are our inverse properties. So you can work them as one-to-one or inverse either way, and they're going to get you the same answer. Okay? So first example. We are to solve e to the 6x equals e to the x squared minus 7. So how do you suggest that we do that? Very good. 6x equals x squared minus 7. Because our bases are alike, that means, bless you, that means the powers have to be the same. So how do we solve an equation like that? We could complete the square. We would need x squared minus 6x. We could bring the 7 to the other side and complete the square. Shall we try and factor it first? Let's try and factor it first. Let's take a minus 7 equals 0. What are factors of 7 that subtract to get negative 6? So negative 7 and a positive 1. So now x would be positive 7 or negative 1 for our zeros, right? Now, with these pesky logs, we always have to think about, what are we taking a log of a negative number? But these are exponents, right? So we can take the e to the 42nd power, and we can take e to the negative 6th power and get a fraction, right? So both solutions are okay. Bless you. Okay? So second example. Now we have 2 times 5 to the x plus 3, and that's equal to 128. How are we going to solve something like that? Okay, we would like to distribute that 2, but if we do that, it can't be, it'd still be a 2 times a 5 to the x plus 3, because they're not like terms. So we'll divide by 2, and 5 to the x plus 3 will be equal to 64. So far, so good. It looks a little less complex than it did. Now, x is an exponent. So what's the inverse operation for exponents, or exponential equations? It's the inverse operation of an exponential function, a logarithmic function. So if we want to make this base go away, which log should we use? Log base 5 would be better, okay? Because if we take the log base 5 of 5 to the x plus 3, our one-to-one property will say that our answer to this side of the equation is the power, x plus 3. But if we take the log base 5 of the left side, we have to be fair to both sides of the equation and take the log base 5 of the right side. So the left side simplifies to x plus 3. And how do we do a log base 5 of 64? How do we calculate that? Change a base formula. So it's going to be, what's your favorite log? Common log or natural? Common, doesn't matter, right? Log of 64 divided by log of 5. All right, so what is the log of 64 divided by the log of 5? So log 64, close parentheses, divided by log 5, and we get 2.584, right? And so what are we going to do to get x by itself? Subtract, so we'll take away 3. And so we take away 3, and we get negative 0.416. Did we get that? X is about negative 0.416. We had to round it so we can put an about equal to sign there. All right, can that be a valid answer for our solution? Yes, because we're taking 5 to a power, and that power would be positive in anyway. Okay, what questions do you have about this slide? Okay with this one? All right, next one. How are we going to handle the one on the left? Thought I heard someone say something. Okay, if we try to divide by 2, we have to remember that this is a power, right? So 2 to some power divided by 2 is just going to subtract a power, subtract 1 from that. Okay, so we could do that, but I don't know that it's going to necessarily help. Okay, yes. Okay, so if we make the bases the same, then the powers are the same, right? So 2 to the x plus 1 would be the same as 2 to the 4th, right? Okay, our one-to-one property says that if we can get the bases the same, then the powers are the same. So x plus 1 will be 4. That means x would be 3. Okay. The other way of looking at it is to use an inverse property. The inverse of an exponential is what? Inverse of an exponential is a log, right? Not necessarily a natural log, but some kind of log, right? And if we have a 2 to some power, then we could take the log base 2 of 2 to the x plus 1 and set that equal to the log base 2 of 16. And this becomes x plus 1, and 2 to what power gets me 16? 4. So we end up with the same result. Okay? Inverses of exponentials are logs, and inverses of logs are exponentials. Okay? All right, next one. That one looks interesting. Now we've got 2 exponents with x. It is like factoring. I'm glad you noticed. Okay? Because this is e to the x squared plus 2 of these e to the x's minus 8. Everyone see that? And if that's confusing for you, you can plug in a different variable. Everywhere we see an e to the x, we could call this y squared plus 2y minus 8 equals 0. How would we factor that? Factors of 8 that subtract to become 2. Factors of 8 that subtract to become 2. Positive 4 and negative 2, right? Okay, so this would be an e to the x plus 4 e to the x minus 2. Make sense? Okay. So what makes our first parentheses equal to 0? E to the x has to be negative 4. What makes our second parentheses 0? Positive 2. Because e to the x minus 2 is the factor. E to the x equals 2 is the 0. And now what are we going to do to make the e's go away? We have e to some power, a base to some power. What's the inverse operation for exponential? Take the log, right? Which log do we want? The log base e, which is also known as the natural log. So natural log of e to the x equals negative 4. And the natural log of e to the x equals a positive 2. But if I take the natural log of one side, I have to take the natural log of the other side, right? What is the natural log of e to the x? X. Can we take the natural log of negative 4? No. So this one's going to be a no solution. Okay. But can we take the natural log of 2? So the natural log of e to the x is x. The natural log of 2 is 693.693. Let me make mine about equal to here. That makes sense? Okay. Started out looking a little crazy. We have to eliminate one of the answers because we can't take a natural log of a negative number. And we have to remember that if we take a log base e of e to the x and a log base e of negative 4, we can solve that. All right, what questions do you have on this one? Doing okay? All right, next one. Now what are we going to do? How do we approach natural log of the square root of x plus 1 equals 4? Could we square it? If we square it, that just brings a 2 to the outside, right? Mm-hmm. Okay, so let's change that to ln of x plus 1 to the 1/2 power. Now what? Can't divide ln on both sides because it's not multiplying, but what's the opposite of natural log? E to the, right? So if we take an e to the natural log of x plus 1 to the 1/2 power, then we'll have an e to the fourth. Whatever we do to the left, we have to do to the right. Okay? Log, or e to the log base e of something is the answer, right? So we'll have an x plus 1 to the 1/2 power is equal to, and we have to figure out what e to the fourth is. So e to the fourth gets us 54.598. About, right? Now, what would we do to get rid of the 1/2 power? We want to take that times 2, right? We're squaring it. So we square the other side. Excuse me. And we get 2,980.5958. So if we subtract 1 from that, we're going to get what? 2979,957 thousandths, 8 thousandths. See how I'm not clearing my calculator all the way along? I'm just leaving that number in there. So we don't want to round it till the very end. Okay. All right, next one. I believe this is the last one. How are we going to solve natural log of x plus the natural log of the quantity x plus 2 equals 5? Condense. Natural log of x times x plus 2 is equal to 5. Now if we want to clear a natural log out, what's the inverse operation for natural log? E. So we'll raise e to it as a power. Or we remember how to write it in exponential form, right? This is log base e. So e to the 5th, the answer to a log is a power, is equal to x times x plus 2. So e to the natural log, they are gone, and we just get x plus 2. And what is e to the 5th? So 148.413. Okay. So now what do we do? We're going to have to use the quadratic formula, because if we distribute this, we'll get an x squared plus a 2x. Is everybody okay with me bringing the 148 to the other side? Now we have to use the quadratic formula, because we probably aren't going to want to, we could complete the square, right? But we can't factor that. Okay, anybody want to see completing the square? Rather do that instead of quadratic? No? Okay. So let's bring our quadratic formula up. Opposite of b, plus or minus the square root of b squared minus 4 times a times a negative 148.413, which is our c, all over 2 times 1. Okay, so that's messy. When we take this number times a 4. Negative times negative is positive, right? So we'll take this number times 4. And then we need to add it to our 2 squared, which is our 4. So plus a 4. And in our radical, we have negative 2 plus or minus the square root of 597.652 all over 2. Okay? Crazy number. Now, let me show you a trick. So we're going to take the square root of that guy. So if you do second square root and then second, the minus or the negative sign is the answer. So we're taking the square root of that answer, and we're going to get 24.2 or 0.446, right? That's the number we're adding to the negative 2 and subtracting from the negative 2 and dividing by 2. So we can store that number. You have a store button on your calculator, and you say, I want to put that into, and you pick a letter. If you say alpha A, the teal on this calculator is alpha, and A is above the math. You can see the teal little a there maybe, if you're close enough. It's going to store that number into A. So now if I want to take a negative 2 plus that number, negative 2 plus alpha A divided by 2. So I'm going to, I need to actually press enter and divide by 2. I didn't put parentheses around it. I get 11.223. Okay. Now if I do our negative 2 minus that number that was the square root, the square root of our discriminant, alpha A, and then we're going to divide that by 2, we get a negative 13.223. So we always go back up and look. Are we taking a natural log of a negative? Yes, right? So we have to eliminate that answer. And our only answer is 11.223. Okay. What questions do you have about this slide? Can you handle it? We're good? All right. Assignment.